Hello and welcome back to this channel. Dear students, today's topic is operations on DT signal, that is discrete time signal part 2. Earlier I have covered in part 1 the different types of operations and how to perform the operations. So before watching this video, please watch that video because it is prerequisite of the video. In the present session, today's session, we will solve few numericals related to this part. What we have studied in part 1, I will just brush up the things. Just check the signs inside the bracket, which is the simplest clue. If inside the bracket opposite sign is there, then perform shift right operation. Shift right the given diagram. If inside the bracket same sign is there, then perform shift left. So shift right you will be performing if there is opposite sign inside the bracket, and this shift right operation is also known as a delay operation. If same sign is there inside the bracket, perform shift left operation, shift the diagram towards left, and it is also known as advanced operation. Now let us solve few numericals. First question is, sketch the signal u of n plus 2 minus u of n minus 3. You can well expect such type of questions. Dear students, again I will repeat, watch the video related to standard or test signals which I have already created, because throughout the subject all these signals are required. Presently I will explain what is required for this numerical. So before performing this operation, let me tell you what is u of n. U of n is known as unit step. N notation is there, so it is a discrete signal. How to draw the diagram? It is unit step. Unit means 1. Mark the scale on x-axis. X-axis is known as n, axis of n. So n is equals to 0, 1, 2, 3 up to infinity. And everywhere amplitude of this signal is 1. This is known as the standard unit step signal. Everywhere amplitude is 1. Now it is asked to perform, it is asked to sketch the signal for this operation. So first term, we have to think term wise. First term, it is u of n plus 2. Look at the signs inside the bracket. U stands for unit step. You just have to check the signs which are present inside the bracket. So inside the bracket, it is n plus 2. Rather, it is plus n plus 2. So same sign is there. Look at the rule. If inside the bracket same sign is there, shift left the diagram. Shift left the diagram. By how much amount? By this amount, which is 2. So I have to shift left this diagram by an amount 2. Look at the original diagram. Always and always do remember one more basic things. Each and every diagram starts from, or read every diagram starting from left to right. So if I want to read this diagram, how I will be reading it? From the leftmost end, the starting value is n is equals to 0, next is n is equals to 1, next is n is equals to 2, 3 and so on. So what's the rule says? U of n plus 2 means shift left. Shift left this diagram, entire diagram, by 2 positions. So new diagram will be like this. How to think? I want to draw the diagram for u of n plus 2. Original diagram was starting from 0. I have to shift left this diagram by 2 positions. So 2 positions means this is minus 1, minus 2. First I will mark the entire scale. It is say till infinity. So I have marked the scale on n axis. This is the n axis. Now I will shift this diagram towards left by 2 positions. It was starting from 0, so it will start from minus 2 because every term will be shifted towards left. So new diagram will be like this. Everywhere you will get amplitude 1. Do remember, amplitude will not change, only starting point of diagram is changed. So amplitude remains 1. This is the diagram for u of n plus 2. I will have to subtract another diagram from this. So I will write minus sign over here. What's the next diagram? Next diagram is u of n minus 3. Again check the signs inside the bracket. It is u of n minus 3, rather plus n minus 3. Plus minus sign. It is n minus 3 means by default plus n minus 3. Plus minus is opposite sign. Opposite sign means shift diagram towards right. By how much amount? This amount is mentioned in the question. By amount 3. Do remember, it is not minus 3. This minus sign is not related to 3. This minus sign just giving an indication it is a delay operation. So forget about all these things. Just remember like this. Opposite sign is there inside the bracket. Shift right. By how much amount? By the amount given by this constant value. So I have to shift this original diagram, that is diagram of U of n, original diagram, by an amount 3 towards right. This diagram was starting from 0. I have to shift it towards right by 3 positions. So new diagram will start from value 3. So below this I will draw the new diagram. First I will mark the scale 1, 2, 3, 4, 5 up to infinity, and everywhere like the previous case amplitude is 1. So this diagram will be starting from 3. So starting point will be this. So from 3, 4, 5 everywhere till infinity, this value of this diagram is starting from 3, and this is the signal for x of n minus 3. So it is starting from 3, everywhere amplitude is 1. Now I have to subtract this diagram from the earlier diagram. How to perform the subtraction? Make the thing simple. You will have to perform term wise. Look at both these diagrams. The first diagram starts from minus 2. So let me first mark the scale on this axis. It is 1, 2, 3, 4 and so on. At this side it is still minus infinity. At the other end it is still plus infinity. Now at minus 2 this value is 1. At minus 2 there is no signal. That means it is 0. I have to subtract it. So subtract means perform subtraction of amplitudes. So this amplitude is 1. There is no amplitude at minus 2. So 1 minus 0 becomes 1. So at minus 2 I will be getting amplitude 1. At minus 1 this is 1. At minus 1 there is no signal. So again this pulse remains as it is. At 0 this value is 1. At 0 nothing is there. So again this value remains 1. So everywhere I am starting getting 1. At 1 it is 1. At 1 again signal is 0. So I am getting 1. At 2 this is 0. At 2 this is 1. 1 minus 0 becomes 1. Now at 3 this value is 1. I will use another color. At 3 this value is 1. At 3 this value is also 1. 1 minus 1 becomes 0. So at 3 I will get 0. Same way, at 4 this is 1. At 4 this is 1. Again you will get 0. Similarly at 5, at 6 up to infinity, everywhere this is 1. 1 minus this value is also 1. It becomes 0. So this is the resultant diagram. Now how to write the sequence? Do remember this is the discrete operation. So after completion of the operation, by default it's compulsory you should write the sequence for this answer. How to write it? Do remember the rule which I have already explained in the previous video. In the sequence, go on writing the amplitude levels. Go on writing the amplitude levels from left to right. Everywhere amplitude is 1. How many times you got 1? 1, 2, 3, 4, 5. So I will write 5 times 1. And rule is that after writing the amplitude levels, anywhere don't write value of n in the sequence. Just read amplitudes from left to right. Presently the amplitude of each signal is 1. So I have written 5 times 1 because I have got 5 pulses. Now another very important rule is at n is equals to 0. What value you are getting? At n is equals to 0 you are getting this middle one. So at middle one I will be marking an arrow. So this is the way how you can sketch any diagram. This is just one example. Keeping in mind only this simple rule, you can sketch any diagram related to the discrete signal. Now let us solve few more examples. The next question is find even and odd parts of the signal. X of n is equals to U of n. If the question can be like this, sketch even and odd parts, one and the same thing. Given signal is X of n, which is equals to U of n. U of n is the unit step. Just now we discussed. For the reference, I have drawn the diagram of unit step. Now recall the formulae to calculate even and odd parts. Even part is given by denoted by x e of n. Suffix e stands for even part. Formula is 1/2 x of n plus x of minus n. Odd part is denoted by x o of n. Formula is 1/2 x of n minus x of minus n. Now I need to sketch the diagrams and then I need to write the answers. First part is 1/2 x of n plus x of minus n. I have the signal x of n because in the question x of n is given as u of n. So this is the diagram of x of n. I have drawn it for your reference. Next, I want x of minus n. Make the thing simple. X of n is the original signal. X of minus n is known as the folded signal. It is also known as mirror image. Keep in mind, in case of mirror, left hand side and right hand sides are interchanged. So, this is mirror image or folding operation. How to draw the diagram without doing any calculation? Directly I will tell you the simple technique to draw the diagram. This is the original diagram which starts from 0 until infinity. Every value, this is till infinity, every value till infinity is 1. I have to take mirror image of this. Since this signal is presently at right hand side, mirror image will be exactly opposite, that is it will be on left hand side. So directly, without doing calculation in the exam also, you can directly draw the diagram. So I will mark some readings for reference purpose. Everywhere amplitude is 1. This is the diagram for u of minus n. That is same as x of minus n, because notation is x of n is equals to u of n. So I have taken the folded version. I have drawn the diagram in reverse way. This is the diagram for u of minus n or x of minus n. Now how to perform the calculation? So first part is calculation of even signal, x of n plus x of minus n. I will draw the resultant diagram over here. This diagram represents x e of n, that is x of n plus x of minus n. I have to perform addition of these two diagrams. Very simple trick. This diagram is actually till minus infinity, but for the sake of calculations I am taking only few readings. First I will mark the readings over here. So it is till plus infinity and this side it is till minus infinity. How to do the calculations? See, at minus 3, I have to add first these two diagrams because this is addition of these two diagrams. So this diagram, first diagram starts from n is equals to 0. There is nothing at minus 1, minus 2, minus 3. So at minus 3 this is 0. At minus 3 this is 1. Everywhere this amplitude is 1. So 0 plus 1 becomes 1. So at minus 3 I will get 1 after adding. Then at minus 2 this is 1. There is nothing. So at minus 2 again I will get 1. At minus 1 this is 1. No signal is there. So at minus 1 again I will get 1. At 0 this is 1. At 0 this is 1. I am adding the diagram. So 1 plus 1 becomes 2. So at 0 I will draw a pulse of amplitude 2. Now at 1 this is 1, but this signal is not present. So 1, this amplitude is 1 everywhere. So 1 plus 0, signal is not there, means its amplitude is 0. So 1 plus 0 is 1. Same way at 2 this is 1, nothing is there. So at 2 again I am getting 1. At 3 again I am getting 1. Likewise this diagram will be till infinity. Everywhere this amplitude is 1. But look at the formula. This is just addition. What formula says x of n plus x of minus n and into 1/2, means make the thing simple. After performing the addition operation, divide each amplitude by 2, means you will be writing amplitude like this. This amplitude is 1, 1, 1. So write it like this: 1 by 2, 1 by 2, 1 by 2. This amplitude is 2. Divided by 1/2. I'm divided by 2. Multiplied by 1/2. So it becomes 1. This is 1/2, 1/2, 1/2. That's it. This is the even part of given signal. Same way, now I want to draw the odd part. How to do it? Just like we have performed the addition, same way now I want to perform the subtraction, because there is a subtraction sign in between. So I have to subtract x of minus n from x of n. I have to subtract this second diagram from the first diagram. Same way as if we performed addition, first mark the readings. So minus 1, minus 2, minus 3 up to infinity. This is 1, 2, 3 up to plus infinity. Now this signal is 0 everywhere before n is equals to 0. So let us start from minus 3. You can start from any point. So at minus 3 this is 1. At minus 3 this part is 0. Keep in mind I will give some figure numbers if to avoid the confusion. This is figure 1. This is figure 2. I have to subtract figure 2 from figure 1. So in figure 1 at minus 3 nothing is there, means 0 is there. At minus 3 this is 1. We are performing subtraction. So 0 minus 1 you will get minus 1. So at minus 3 you will get minus 1. Same way at minus 2 nothing is there. At minus 2 this is 1. 0 minus 1 becomes minus 1. Same way at minus 1 also you will get minus 1. Now add 0, this is 1, add 0, this is 1, 1 minus 1 becomes 0, so add 0, we'll get 0. Next, at 1, this is 1, at 1, 2, 3, now onwards, nothing is there. I have to subtract this figure 2 from figure 1. So 1 minus 0 becomes 1. So I will start getting 1, 1, 1 till infinity. Now, this I have just completed the term related to square bracket. Every amplitude is multiplied with 1/2. That means every amplitude, after drawing this diagram, every amplitude you need to divide it by 2. So this I will write it as 1/2, 1/2, 1/2. Same way this is 0, no issues. So it is 1/2, 1/2, 1/2. This is the odd part of the signal. So this is the way how you can calculate even part and odd part of the signal. Let us solve one more example related to this type. The next example, question is find even and odd parts of the signal. X of n is u of n minus u of n minus 4. Dear students, usually the questions are related to unit step because it is a standard signal. So first I need to sketch this signal. For the reference, I have drawn the diagram of u of n. Just now we discussed this diagram. It is unit step starting from 0 till infinity. Its amplitude is 1. Minus, that means I have to subtract another diagram. What's the another diagram? U of n minus 4. We just now discussed this thing. Check the signs inside the bracket. This is plus n minus 4. N minus 4 means plus n minus 4. So opposite sign is there. If inside the bracket opposite sign is there, shift the diagram towards right. By how many positions? By 4 positions. Look at this diagram. This diagram is starting from 0. How to identify starting point? Once again, start reading every diagram from left to right. So starting point is leftmost point. So this diagram starts from n is equals to 0. On this axis, we are plotting scale for n. So I have to shift this diagram towards right by 4 positions. It is starting from 0. I have to shift it towards right by 4 position. Means new diagram will start from 4. It was starting from 0. Shift towards right by 4 positions. Means it will start from 4 and it will be till infinity. Amplitude is 1 everywhere. Now let us perform the subtraction same way what we did in the previous sum. So at 0 this is 1. Up to 3 there is nothing in the second diagram. So I will first mark the scale 1, 2, 3, 4, 5 and till infinity. Now at 0, 1, 2, 3 everywhere this amplitude is 1. So at 0, 1, 2, 3 there is no signal. So if you subtract no signal means 0. If you subtract 0 from 1 it will remain 1 itself. So up to 3 I will mark values. I will mark the pulse of amplitude 1 everywhere. Now at 4 this value is 1. At 4 this value is 1. 1 minus 1 becomes 0. Same way at 5 this is 1. At 5 this is 1. 1 minus 1 becomes 0. And now onwards at 6 again it is 1. At 6 again it is 1. We are subtracting. So everywhere you will start getting zeros. So this is the resultant diagram. Do remember we haven't yet completed the solution. We just obtained the given signal x of n. So now this is the diagram for given signal x of n. To do this calculation, I need to write the sequence from this diagram. Recall the rules how to write the sequence from this diagram. What I said earlier, if this is the diagram, everywhere amplitude is 1. Writing the sequence means write it like this: x of n is equals to, go on writing all amplitudes from left to right. So everywhere amplitude is 1. So I will write 4 times 1. 1, 1, 1, 1. Now at n is equals to 0, we have first one value. So at first one value, mark an arrow, because every time at n is equals to 0, you need to mark an arrow. Now actual problem starts. We have to calculate its even and odd parts using this formula. This is the same way what we have solved one numerical right now, but I will tell you another simple trick how to solve such type of numericals. Earlier it was related to unit step till infinity, so I have drawn the diagram and I told you the procedure how to solve the numericals. There are only finite signals. Look at the formula. I don't now want to draw the diagram. Directly I will tell you how to obtain the solution. It is x of n plus x of minus n. This is the diagram, sequence x of n. If I want to write the sequence x of minus n, how to write it? it should be folded version or mirror image. Mirror image means write the sequence in reverse order. So it is 1, 1, 1, 1. Arrow will be at last one because earlier it was at first one. If you take mirror image, if you fold this signal, arrow will be at last position. Same way, suppose if you are getting confused for this part, suppose given signal is x of n is equals to 1, 2, 3 and I want to write x of minus n. How to write it? Suppose arrow is at 1. Write the sequence in reverse way. Reverse way means it is 3, 2, 1 and keep arrow as it is. Arrow was at 1, so I have kept that arrow at 1. Same way here, but only the amplitudes are same. So I have written the sequence in reverse way, 1, 1, 1, 1 and kept arrow as it is. So arrow will be at last position. Now, how to perform the addition without drawing the diagram? See, I will write these values over here, 1, 1, 1, 1. These are the values for x of n and arrow is here. I will mark it over here or if you are getting confused, I will mark arrow over here. Whatever values I have not written, by default these are zeros. Now second signal, arrow is at this position, so second signal below this I will write it like this. I'm writing sequence x of minus n. Arrow should be matching, so this is 1 and here I will write 1. This is the second, here I will write, this is the second sequence, 1, 1, 1, 1. What I did, I have written first sequence x of n, this sequence, arrow was at first position. Below that I have written second sequence as if I am drawing the diagram, but I am directly doing calculation. So arrow was at this position, every samples are at left hand side. This is sequence of x of minus n. If you take addition, so if you take addition, I will write plus sign over here. I will write it like this, 1/2 and plus. Why 1/2 and plus? Because you have to perform addition and then divide amplitude by 2. We'll discuss this division of amplitude by 2 later. First we will perform the addition. So look here, whatever values I have not written, mark zeros over there, 0, 0, 0. Same way, whatever values I haven't written, I will mark zeros. Perform addition. So after performing addition, I will get addition of this 1 and 0, 1, 1 and 0, 1, 1 and 0, 1, 1 plus 1, 2, this is 1 plus 0, 1, this is 1, this is 1. So simply I have performed addition, but it is 1/2. So after performing addition, write amplitude like this, 1/2, 1/2, 1/2, 2 by 1, or 2 by 2 is 1, then again 1/2, 1/2, 1/2. This is the answer for even part of the signal. By default, arrow will be here. So this is the answer for even part. You can write it in the sequence. Now, same way. Now I want to calculate the odd part. So for odd part, this was the even part. I will remove this part. For odd part, instead of addition, I need to perform subtraction. So it is 1/2 and then subtraction. Same way, what I have to do? I have to subtract the second signal from first one. 0 minus 1. You will get a minus 1. This is 0 minus 1, minus 1. 0 minus 1, minus 1. 1 minus 1, 0. Then 1 minus 0, 1. 1 minus 0, 1. And this 1 minus 0, 1. And after that, it is 1/2. So divide every amplitude by 2. 0 by 2 is 0 itself. So it is 1/2, 1/2, 1/2. By default, maintain this arrow. Arrow will be at this position. So this is the answer of odd part of the given signal. So dear students, these are the methods, quick and simple methods to calculate or to perform operations on the discrete time signal. So if you have got this method, then you will be in a position to solve any such numericals. So that's it for today's session. Thank you. Thanks a lot.